I'll show you why. And so the reason is, and why we focused on words before. So it says at a football game they sold $4 pizzas and $2 sodas, which made the school $260. The number of sodas sold was 5 more than 3 times the number of pizzas sold. Determine the amount of pizzas and sodas sold. So I'm just going to help you set this up. This one's just a little bit different. And so this one still is like money goes with money goes with money. But first, let's define our variables. What do they talk about first? Pizza. So I'm going to make pizza. So the pizza's X, and then your Y is going to be soda. So I know a pizza was how much money? $4 for a pizza. So I know it's going to be 4 per pizza. How much per soda? $2 per soda. And how much money total did they make? 260. So that equation's still the same. That's why I knew you kind of were going to ask. Now, the second one is if total goes with total. It's almost like a substitution. We got to read what's making sense here. And so it says the number of sodas sold. So I know when they're saying the number of sodas, what letter am I looking at? Which one sodas? Y, right? And so I know the number of sodas sold was or is. What is or was? What sign does that mean? Equals, right? Like if something is, if you are 15 years old, you equal 15. So the number of sodas sold was 5 more. So 5, if I have 5 more than you, plus 5, 5 more. You can do it on this side too if you want to do y equals on this side. But y, you mean plus 5? Why is it on the opposite side? Because it's 5 more than 3 times the number of pizzas. So how do I know pizzas is my x, and if it's 3 times that, what would be next to it? A 3.
All right.
And so it's 5 more than 3 times the number of pizzas. So sometimes, most of the time, it's going to be the ones that we did yesterday, but sometimes it will be substitution like this. Then it says determine the number of pizzas and sodas sold. So I'm not going to go through the rest with you, but see how a variable is by itself? So what would we do here? Would we use elimination or substitution? Substitution, right? So when we substitute, instead of y right here, you're going to plug in 3x plus 5. So it's back to substitution practice. Does everyone understand what I mean by that? Like when you're writing this equation again, I know, okay, it's 4x plus 2 up. Y's tired. Who's taking y's place? 3x plus 5. So that's back to substitution. Equals 260. Now see if you can go ahead and solve that while I pass out your next. So see if you can go ahead. So distribute, combine like terms. We'll go over it in a second.
What? No.
Nope. Because you already distributed. Now just combine like this. Yeah.
Is there a version?
Now plug it back in. So remember, you could plug it back into either of these equations, and you're solving for x. The easiest one is probably this one. So all you have to do is plug it in right there. Sorry. All right, so at this point, I saw at least some of you guys distributed and got 4x plus 6x plus 10 equals 260. How many people got that far? Awesome, we're on the next one. Then we combine my terms. So 4x plus 6x is 10x plus 10 equals 260. How many people got that far? Awesome. Then we subtracted 10 on both sides to get 10x equals 250. And then divided by 10. And what did you end up getting for x?
25.
Beautiful. And so 25, we know, represents, when we go back up, it represents the number of pizzas sold. To find the second one, you plug it in, plug it in. Now I'm going to plug it in the second one because that looks a lot easier. So what is 3 times 25?
80.
Oh, 3 times 25 is 75 plus 5 is 80. So this is just substitution. And so when you scroll down, what label what they represent, we know that 80 represents the number of soda sold. And what does 25 represent?
The number of pizzas.
Good, number of pizzas sold. All right, the last type of problem we're going to go over for today is that little sheet of paper, because I kept changing my mind of what I wanted to do. So this one's on a half a sheet of paper. And so read over the question, and these are back to like slope-intercept form, so like y equals mx plus b. Because it's your initial value and what's adding each time. And so this is back to like a couple units ago. So we're going to do this one right here. So this is the last one I'm going to go over with you, then you can just practice it. So the gardener is planting 2 types of trees. Type A is 3 feet tall and grows at a rate of 15 inches per year. Type B is 4 feet tall and grows at a rate of 10 inches per year. So see how this is a little bit different? This is back when we were writing y equals mx plus b, right? And so we have our initial value and our slope. And so when I'm writing our y equals mx plus b, what word indicates that something is your slope? Do you guys remember? Rate and per, right? So it grows at a rate of 15, so 15 would be your slope, inches per, and then remember what after that per is your domain, your x. So what would your x coordinate be? Or what would your x, what would we label for x?
X.
It's per year. So x indicates your years. And so this one's a little different because when it's in slope-intercept form, like this, whatever's after per, each, every, is your x, your domain. Then remember your y is always your total. And so when we're looking at these trees, they're talking about total feet. And so notice that the whole equation is not in feet. We're going to have to play around with it, or sorry, not feet, total inches, because it will be easier to get it to all into inches. Can't speak to it. And so we have 3 feet tall and grows at a rate of 15 inches per year. So notice there are 2 different units. And one is 4 feet tall and grows at a rate of 10 inches per year. How many inches are in a foot? How many inches are in a ruler? 12, right? So if something's 3 feet tall, what do we multiply 3 by? 12 to figure out how many inches. So how many inches is 3 feet tall? 36 inches. So maybe cross out 3 feet tall, 3 feet, and put 36 inches. So it doesn't confuse you. So you need everything in the same unit. Yeah. Then we have 4 feet tall. And so what are we going to be multiplying here? 4 times what? How many inches are in a foot? Well, you get 48 inches. Now we got to write them in y equals mx plus b. So let's look at type A, right? I'm going to put type A first. And so we have y equals, what's the slope of the first one? What's the number that's before per? 15, right? Do you guys see that? And so 15 would be your slope. 15x plus, how much does it initially start as? How many inches? 36. So this is all in inches. Then the next one is type B. And so I know type B, how many inches is it growing per year? The 10, right? So it's growing 10 inches, whatever before per year. Then plus how many inches does it start as? 48. And so this isn't anything that's really new. This is from last unit. But you do need to remember how to put things into slope-intercept form. And now we can see they're both equal to y. Do you guys see this? See how they're both equal to y? What will we use to solve them? Elimination, substitution, or graphing? But elimination says x and y are on the same side. Substitution, right? Because they're both equal to the same thing. Remember this? This is under check for understanding if you want to look at it. And so we know that this would be substitution because we could just make them equal to each other. Right? Because they're both equal to the same thing. Remember, we just make them equal to each other. So to solve for your variable, I would do, okay, if they're both equal to the same thing, I'm just going to write it out like this. 15x plus 36 equals 10x plus 48. So we want to find our x right here. So you're making them both equal to each other because they're both equal to the same letter. Then you draw your river and solve. So this is like a couple lessons ago. So who can raise their hand and tell me what would I move first here? It doesn't actually, there's not a right answer, but sure. How would I move 10x to the other side? Subtract it, right? So to get it over the river, I can't just combine because there's an equal sign. So I subtract 10x on both sides. And what is 15 minus 10? What do I do next?
Subtract.
Subtract what? Good. Subtract 36 because we want the constant all on one side. And you get 5x equals 12. Then what do you do? Divide. x equals 2.4. And so when we're looking at this, what does x represent from the, what do we label x as? Years.
Years.
So in 2.4 years, they'll be the same height. So in 2.4 years, they'll be the same height. And sometimes the question will just ask that. Sometimes they'll be like, okay, well, how many inches will they both be when they're equal? To find that out, I gotta plug it back in and solve for my second variable. Does it matter which equation I plug it into? No. I'm gonna just plug it into the second one because I can see it right now. Y equals 10x plus 48. And what do you get as your x? 2.4. Then you just solve. What's 10 times 2.4? 24 plus 48. Mm-hmm. And so I want to make sure I understand what that means. So y represents what? Inches, right? So in 2.4 years, they'll be 72 total inches. Does that make sense? So what we're going to be practicing it with is round 3 and 4. If we get to inequalities, awesome. We may not have a chance to get to it today. That should be a review though. But I want you to try number 3 and 4. But first, the fourth round is messed up, so I want you to turn to round 4. I typed it wrong. Actually, the question was written wrong, but I figured out what they did. So if you go to question 4, round 4, see how it says the number of dimes? You guys see that? I think actually, did I fix it? No. I didn't. So the number, it's not dimes, it's the number of quarters. Is 3 times the number of dimes. So fix that. So in round 4, go to round 4. It's the number of quarters is 3 times the number of dimes.